Hey, this is part 2 of 6.1 because apparently in all the commotion and all the people and stuff, I pressed stop instead of pause. Well, let's take a look at these alligators. Let's see how they're doing. I played this out down here, and here's the equations I came up with. Alligator 1 is going to be 1.5 pounds times each month plus the original 4 pounds. That's played out on, got my line in blue. And then the second alligator in red is 1 pound per month. So 1 times T is played out right here, plus the original 6 pounds, we saw in red. And we can see here that they intersect right, looks like right around here. That would be my solution. So 1, 2, 3, 4 months. It's at that 4-month mark that is my solution to this system. All right, why don't you press pause and try this one with satellite radio fee. Build your 2 equations. Use your equations, what you know about them, to graph, find that intersection. And that ordered pair is your solution to that system. All right, let's see how you did. Here's my equations. Cell phone company 1 is 10 times each month plus the additional $20, which is in purple, and the green is $11 per month plus the 15 fee. And it looks like they meet up at around 1, 2, 3, 4, 5 at the 5 mark, 5 months. And that's what we come up with. Hope you did it. Take a look at everything. Make sure you're seeing it. Now here's some definitions. Don't just read through them. Please consider writing them down so you can keep track of all this stuff. Because as these graphs interact with each other, as these systems come up with solutions, they have specific names for them. Like a system of equations. Here, a system of equations that has at least one solution is consistent. Okay, so if I do see an intersection or if I see an overlap going on, I can say that these are consistent. A consistent system, though, is either going to be independent or dependent. It will be independent if it only has one solution, and that kind of what happened on my our first 2 examples where they intersected. And a system could be dependent if it has an infinite number of solutions. Infinite number of solutions would be if 2 graphs lay on top of each other. Maybe you've heard that called collinear in the past. And then also, a system equation that has no solutions would be considered inconsistent. No solutions would include there's no intersecting going on. We might see it as something parallel. So if there is at least one solution, it's consistent. And then when it is consistent, it is either independent or dependent. So as you look at these systems and as we use the language of it, please continue to get comfortable with it. Problem 3, I did this already, but it wasn't recording, but here we are. For A, what I did is I had to take my equation and put it into point or slope-intercept form, just so I could see what's going on. And when I did that, I found out that both my equations were identical. So when I graphed it out, both the lines were laid on top of each other in a collinear situation. And in that case, it does have a solution, so it is consistent. And because it is an infinite number of solutions, we'd call this dependent. So this is a consistent and dependent system here. And then for B, I looked and I noticed they both have the same slope, as indicated in the red here. They both have the same slope, so, and I can see that their y-intercept changes, so these lines will never intersect. So because there's no solution, we would call this inconsistent. Why don't you press pause and play this out a little bit and get comfortable with the language of it too. So you're gonna let me know, do they intersect at one point, at all points, at no points, and when it does, what does that mean? All right, for A, I can go ahead and take a look at this, and I see in A, both of them have the same slope. They have the same slope, but their intercept changes. So these 2 lines are going to be parallel. So there's no solution, so we would call these inconsistent. No solutions. For B, it actually is a little bit undisguised. I'm going to change this one into slope intercept form. And when I do that, I notice a couple things. I can see that it does have the same slope, and it actually has a matching y-intercept. These equations are the same, so they would have an infinite number of solutions. So because it has a solution, it is called consistent. Because they're infinite, it is also dependent. And I answered number C a little bit when you start looking at slopes and the such. All right, let's wrap this up. Make sure you take a look at these different things. Make sure you have good notes about things. What happens when you have one solution that's playing out as an intersection and one coordinate? There's some names that are involved with that. You could have an infinite number of solutions where the lines are collinear. There's some language that comes along with that, some vocabulary. And there's no solution where the lines are parallel. And there are some vocabulary words that play along with that. All right, so that's it. I am going to continue to walk around floor number 24 and eat my tuna sandwich, courtesy of the government.